Alrighty guys, 9.2, we are getting into parabolas. Now, we've studied parabolas before, but we've never looked at them like we're going to look at them today. So take good notes, review this video in the future if you need to, but here we go. We have two objectives for today. We're writing equations of parabolas in standard form, and then we're graphing those parabolas. So let's define what a parabola actually is. So there's some new terminology here for parabolas. Up until this point, we graphed parabolas using like a standard general form for an equation for one of these in quadratics, and we did this in Algebra 1. But now we're going to define it a little better. So a parabola can be defined as the set of all points in a plane that are the same distance from a given point called the focus. Okay, so if you see here in the picture the focus, there's that point there that's in the like in the middle of the parabola, where all points in the plane are the same distance from that as they are to this line here on the other side of the parabola called the directrix, this guy. Okay, so the distance that is between the actual graph and the focus and the directrix will always stay the same. Okay, so I'll show you guys another picture of this later, but essentially this distance that's here, I don't know if you guys can see that, but I'm drawing it right there by the vertex. This distance here from, and that's a perfect 90-degree angle from the focus to this vertex of this graph is the same as the distance from the directrix to the vertex, but it's true for anywhere on this thing. Okay, so if I were to draw a point from like here down to this focus and straight down here, that distance would be the exact same always. The line segment through the focus of a parabola and perpendicular to the axis of symmetry is called the lattice rectum. So let me just, that is a very funny term, I know, but the lattice rectum is, it always goes through the focus and touches the actual graph, okay? And the length of that thing often, that thing is determined by what we call the A value, which we'll see here in a minute, but it is just like the A value that we studied in quadratics. So this is the most important chart for this whole lesson. All right, so if you can understand this chart and how this chart kind of works, you'll be fine. And I know it's a lot, but just refer to it often and it'll start making sense. So in Algebra 1, we studied parabolas that typically were, vertical in nature. There were a y equals. So that's going to be this side of the chart. The stuff that you're super familiar with is going to be a y equals. It opens up or it opens down depending on if A is positive or negative. Okay, a couple things about this. Today we're going to put these things into vertex. This is called vertex form. Okay, so whatever makes this guy go to 0 followed by this guy is going to be the vertex. And it'll become more clear later, but the axis of symmetry will always be, in this case, will be your x value there, which is your h value in vertex form. So whatever your the x value of the vertex is, that's going to be your axis of symmetry, obviously. And then your focus will always be the point h, because it'll have the same x value, right? Same x value. The focus, if you're looking at a picture that looks like this, if the vertex is here, and your focus is up here, the h value is going to be this, which is, so this guy is at h comma k. The focus will have the same value as h, but then this distance here will always be k plus 1 over 4a. Okay, k plus 1 over 4a. And the algebra behind that's a little bit complicated, but and you can look it up, and I can give you some information on that. But for now, just know that it's k plus 1 over 4a. And then the directrix will always, this line here, will always be y is equal to k minus 1 over 4a. Okay, because from this distance we're going in the opposite direction. And then the length of the lattice rectum through this guy here will always be 1 over a units. Okay, it's the exact same thing for parabolas that open left and right, except for now we have an x equals, so all the x and the y swap. The vertex is still at h comma k, but notice that k is now inside of the function and h is on the outside. Okay, so it's like swapping x for y. And then we have h plus 1 over 4a, so since we're going the other direction, now we have to modify the h value instead of the k value, and the k value stays the same. Okay, so that's really the only difference. And we'll refer to this chart a lot, okay, so keep that thing handy. So the general form of an equation for one of these things is y equals ax squared plus bx plus c. This is what you're used to, okay? If you have an equation in this form, it can definitely be written in the standard form or in the vertex form. And then the shape and the distance between the focus and the directress depend on the a value in the equation. Okay, so how wide it is, and how, well, essentially, yeah, how wide or how skinny it is dependent on a and whether or not it's flipped upside down or not. So example 1 says they want us to write this thing in standard form. Okay, in standard form, that is another name for that is vertex form. So they want this in vertex form. Okay, so we're going to do some completing the square like we did in the introduction to the chapter. Then we're going to identify the vertex, axis of symmetry, and the direction of opening. Okay, so for this one, what we need to do is we need to complete the square. So I'm going to show you a little bit of a trick with completing the square here. Typically, what we did in the intro to the chapter here is we said, okay, the first things first, we have to get rid of this 4, right? So typically we would just divide everything by 4. But what I'm going to encourage you to do, if 4 doesn't go into this guy nicely, is just separate the 34 out from the x terms, okay? Which we can do as long as we keep everything balanced. So what I'm saying by that is, let's rewrite this as y equals, we're going to take a 4 out of these pieces. Okay, so 4x squared plus 4x, okay, and then I'm going to leave a blank because I'm going to complete this square here so that this factors nicely. And this is going to be plus 34. Okay, now what I need to do, because typically we move that constant to the other side of the equal sign, but I don't want that because I want this y equals to stay over here. So whatever I add in here, I actually have to subtract on this side. Okay, so if I add something into, one side of an equation, if I'm not going to add it to the other side, I have to subtract it, in another part of the equation. So here, to complete the square, I'm going to take half of 4. Half of 4 is 2 and square it. 2 squared is 4, so this becomes a 4. But I did not actually add in 4 here, okay, because there's a 4 that it was taken out. So I have to apply that. 4 times 4 is actually 16. So I'd actually added in 16. Okay, so if I add in 16, I have to subtract 16. Okay, so now what I'm left with is y is equal to 4. And the reason I complete the square here is because this now factors nicely. Remember, it's the root of that, which is x, with this sign. So it's plus, and then the root of my final term there, which is 2 squared. Okay, and now 34 minus 16 is equal to 18, so plus 18. Okay, so didn't change the value, just rewrote how this looks. Okay, now look, why I did this is I want it in this form because this form is the standard form for an equation for one of these parabolas. Okay, so now that I know that, I can identify what the vertex is very easily when it's in this form. So that's the reason we do this. So the vertex is whatever makes this guy go to 0. So in this case, that would be negative 2, okay, followed by this guy, 18. And the reason that the negative 2 came first is because this is a y equals. So if it was the other way around, then that negative, then the h and the k would be switched. So there's my vertex. Okay, now that I know my vertex, they want to know the axis of symmetry. Well, this is opening up and down. Okay, so if you imagine negative 2, 18, somewhere up in here, right? We'll just say that that's negative 2, 18. If that is opening up and down, in this case it's opening up, right? So it's something like this. I don't really know exactly what the shape is yet, but the axis of symmetry is just going to be this guy, right? So if my vertex is at negative 218, my axis of symmetry then would be x is equal to negative 2. There's my axis of symmetry. There's my vertex. And then, and then it says the direction of the opening, which we just talked about. So since this is positive, this is opening up. So opens up. Okay, and that's all they want to know, those three pieces. So that's example 1, is just getting you used to writing things in standard form. Okay, so example 2 says graph this equation when the equation is solved for y. Okay, so all they want you to do for 2a here is just plug in values for this thing. You know, so we can make a little chart if we wanted to, so we can do x, y. You know, plug a 0 in for x, I know that my y will be 0, right? So this thing's going to have a vertex that's going to be there, I'm assuming. So then plug a 1 in. Sorry, when you plug a 1 in, you don't get a 1 out. If you plug a 1 in, you get a 2 out. So at 1, we're at 2. If you plug a negative 1 in, you're also at 2. Okay, and then you can just keep going here. If you plug a 2 in, 2 squared is 4. 4 times 2 is 8. So 2, 8, and negative 2, 8. And there's your graph. So for now, they just want you to be comfortable with that in example 2a. Okay, but then 2b, now things change a little bit. So before you graph this, what I would encourage you to do is identify your vertex. This is a y equals, so it's opening up because my a value is positive. Okay, so I know that it's going to have this general shape. The vertex here is going to be whatever makes this go to 0, which is 1, followed by this, negative 4. Okay, so at 1, negative 4, I have the vertex. Okay, so that means my axis of symmetry is also going to be here because it's opening up. It's a y equals. Okay, so axis of symmetry is at x equals 1, and it opens up. Okay, so now what I want to do is, you know, at this point, I can either start using my chart here to figure some of this out, or I can plug values in, right? So I can continue to plug some values in. Since I know this opens up, I can plug like a 2 in and see what happens. So if I did that here, plugging a 0 in would be interesting. Plugging a, well, let's plug a 0 in. But if I plug a 0 in here for x, what I'm going to end up with is negative 1 squared, which is 1. 1 times 2 is 2. 2 minus 4 is negative 2. So at 0, I'm at negative 2. So I would assume that if I plug a 2 in, I'd get the same thing. And that is true. Okay, so you kind of get an idea of what's happening here. But let's maybe plug in one more. So let's plug a 3 in. I think a 3 would be a nice number to plug in because this would make that go to 2. So if I plug a 3 into this, I get 2 squared, which is 4. 4 times 2 is 8. 8 minus 4 is 4. So at 3, I'm at 4. Okay, and now I definitely get the general shape. That means at negative 1, I should also be at 4 because of symmetry. And there's my picture, right? Okay, so notice right now we're not focusing on the latus rectum, the focus, the directrix, anything like that, but we're about to. Okay, so now, steps to graphing equations in general form. What we're going to do is we're going to write the equation in standard form or vertex form first. Okay, so write it in standard form or vertex form first. So it says here, write the equation in the form x equals a times y minus k squared plus h if there is a y squared term, or y is equal to a times x minus k squared plus h if there's an x squared term. So it depends on which term is being squared. Use the equation to find the information about the graph and then graph it. Okay, so those are our steps. On 3a, you might have a mistake in your notes, so if you need to switch this, that should be a 4y plus 25, not 4x plus 25. That's a mistake in the book. So for 3a, we have a y squared term. Okay, so since we have a y squared term, what we're going to do is we're going to move that guy over here. So we have 3x is equal to y squared plus 4y plus 25. Okay, what I want to do for this is I want to then complete the square and put this into vertex form. Okay, so I'm going to just keep this as 3x over here, and then I'm just going to separate this out. So we have y squared plus 4y. We're going to put this plus 25 over here, and then we're going to put a minus something and a plus something here. Okay, so that we keep the equation balanced. Whatever goes here must go here. So if I take half of 4, I get 2. 2 squared is 4. So I'm going to add a 4 in, which means I'm going to subtract a 4 here. So now I'm left with 3x is equal to, this will factor nicely now to y, the root of this guy, plus the root of this guy, which is 2 squared. And then 25 minus 4 is 21, plus 21. Okay, now what I need to do is get x by itself. So I'm going to divide everything by 3. So x is equal to, if I divide this whole thing by 3, it's just 1/3. Right, 1/3 y plus 2 squared plus, take 21 divided by 3, I get 7. Okay, so this now is in the form that I would like. All right, that's the form that we need. Okay, if I'm going to go to graph this, this is an x equals now. So since this is x equals, I know that this is going to go, and this is positive, I know that this is going to open to the right. That's going to be the general shape because it's an x equals. Okay, so let's put the vertex in there. So the vertex is, notice now here, you got to be very careful. This is the y value, that's -2, and the x value is 7. Okay, so the vertex is here at 7, -2. Okay, so 7, -2. There's my vertex, which means my axis of symmetry is also here because it's opening to the right. Okay, and so I know that it's doing something like this, right? Okay, so I need a couple more pieces of information here. So what I could do is I could choose to plug values in. That's fine. And at this point, you know, they might have you do that. But let's work on like what the focus would be for this. So the focus and the directrix for this, if you refer back to your chart here, which we'll do a lot of, okay, the focus of this thing is going to be at h plus 1/4a comma k. And the directrix will be at h minus 1/4a. Okay, so back to here. Okay, so I need, since I know my focus is going to have the exact same y value, but a different x value. I know that the y value will remain -2, and the x value would be k plus 1/4a. Well, I know what my k value is. Sorry, I should say h. H plus 1/4a. I know that my h value is 7. Okay, so it's going to be 7 plus 1/4a. Well, I know what a is. A is always this number that's out in front. It's 1/3. Okay, so it's going to be 7 plus 1/4 times 1/3, which is 1/4 thirds, which if we flip that and multiply becomes 3/4, so it's at 7 3/4. Okay, so my focus is at 7 3/4, which doesn't really help me very much, somewhere in there, which means my directrix is somewhere in here. Okay, so as far as graphing goes, you know, it's not super important, but if I plug that back into my equation, what I can find is I can find my lattice rectum, which helps me determine how wide this is. Okay, so I could do all of that, and we're going to do that very soon, but let's just see what happens here if I plug in a, well, let's just see what happens if I plugged in an 8, for instance, for x. So if you plug in an 8 for x, okay, and you can also choose y values to plug in. So we could, let's do that. Let's plug a y value in. So since this is going the other way, let's plug a y value in. So if I plug a y value in, let's plug in a 0 just to see what happens when y is equal to 0. So if I do that, then I would get 2 squared, which is 4. 4 times a third, which is 4 thirds, plus 7. So that becomes 8 1/3. So at 0, I'm at 8 1/3. Okay, so we got that kind of a shape happening, which means that at -4, I should also be there. Okay, so we kind of have that shape in general happening. Now you could keep going and you can plug a 2 in, right? If you plug a 2 into this for y, that becomes 4 squared. 4 squared is 16. 16 times a third is 16 thirds, which is what, 5 1/3? 5 1/3 plus 7 is 12 1/3. So if I plugged in a 2, I'm at 12 1/3. So I'm somewhere in there, which means that at -6 I should also be there. Okay, so there's the general shape of what this thing should look like. All right, so for now, just be comfortable with that. We'd have, there'd be a lattice rectum through here and some other things that we need to identify eventually, but for now, just plug values in for example 3. Now, example 3b, for this guy, we're going to do the exact same thing. So we have y equals, and I encourage you to pause the video here now and try this one out on your own. Okay, so complete the square here. So I have x squared plus 6x minus 4. Half of 6 is 3. 3 squared is 9. So plus 9 minus 9. Okay, so this becomes y is equal to x plus 3 squared. -4 minus 9 is -13. So now I know that I have a vertex on this one at -3, -13, since this is a y equals. So my vertex, -3, -13. This thing is opening upwards, has an axis of symmetry through that thing. Okay, so now again, choose some values, plug them in, get your other values out. So if I did that on either side of this, we can plug in, and we're going to choose x values here. Let's plug in -2, for instance. So if I plug in a -2, -2 plus 3 is 1. 1 squared is 1. 1 minus 13 is -12. So at -2, I'm at -12, which means at -4, I'm at -12. Okay, plug a 0 in. Plug a 0 in, I get 3 squared, which is 9. 9 minus 13 is going to give me -4. So at 0, I'm at -4. And that means at -6, I'm at -4. Okay, and that's really all you need, is those key points there to get your shape. And you're done.